Good morning, students. How are you all? Hope you all are fit and fine. Students, last week you have done sums from determinants, and today I am going to teach you a new chapter, that is indeterminate forms. Before I start explaining of this chapter, I would like to remind you that in class 11 you have done one chapter, that is limits and derivatives. In limits there are many criteria was there, and just look, you have done this criteria in class 11. If limit x tends to c, f of x exists, and limit x tends to c, g of x exists, then we can write limit x tends to c, f of x by g of x equals to limit x tends to c, f of x by limit x tends to c, g of x, only when limit x tends to c, g of x not equals to 0. Remember this. We can write this when limit x tends to c, g of x, that means denominator part not equals to 0. That part we have done in class 11, and we have done few sums related to this property. Okay. Now the question is, if denominator part is coming 0, that time what we will do? That means if limit x tends to c, g of x is coming 0, then how we solve this sum? Okay. Now then that means, look, suppose if limit x tends to c, f of x equal to 0 equals to limit x tends to c, g of x, then f of x by g of x we assume as the form of 0 by 0, that is indeterminate forms. When limit x tends to c, f of x is 0, as well as limit x tends to c, g of x is 0, that time limit x tends to c, f of x by g of x we assume as the form of 0 by 0, which is known as indeterminate forms. There are many types of forms like this 0 by 0. There are infinity by infinity form, infinite by infinite form, infinite minus infinite form, 0 into infinite form, 0 to the power 0, etc. These are all indeterminate forms. Okay. Now in 2020-21 batch, that means your batch, there is a reduced syllabus, and in your syllabus only two forms are there in your syllabus, that is 0 by 0 form and infinity by infinity form. That means you have to do sums related to these two forms. One is 0 by 0, another one is infinity by infinity. And we are not doing this type of sum, that is infinity minus infinity, 0 into infinity, 0 to the power 0, no need to do. Only these two types sums we just practice, that is 0 by 0 and infinity by infinity form. Okay. Now how we will solve this type of sum? If I want to solve this type of sums, we all have to know one rule that is known as L'Hopital's rule. L'Hopital's rule. L-H-O-P-I-T-A-L apostrophe S, Hopital's rule. Someone can tell L'Hospitals also. Okay. So L'Hopital's rule. What is L'Hopital's rule? Hopital's rule. If limit x tends to c, f of x equals to 0 equals to limit x tends to c, g of x, and limit x tends to c, f dash x by g dash x exists, then only we can write limit x tends to c f of x by g of x equals to limit x tends to c f dash x by limit x tends to c g dash x. By this rule we can write that limit x tends to c f of x by g of x equals to limit x tends to c f dash x by limit x tends to c g dash x. That is L'Hospital's rule or L'Hospital's rule. Okay. Now how to solve the sum? Just check. Suppose one sum is given, limit x tends to 3 x to the power 4 minus 81 by x minus 3. How we solve this sum? By L'Hospital's rule. Okay. Look, if I put the value normally x tends to 3, that means 3 if I put it in place of x. Look, 3 to the power 4 is 81. So 81 minus 81 is coming 0. And denominator also, look, if I put 3 in place of x, 3 minus 3, it is coming also 0. So it is 0 by 0 form. So you have to write this way. 0 by 0 form. Use L'Hospital's rule. You have to write, this is compulsory, you have to write this. So look, if I put the 3 is here in place of x, 3 to the power 4 is 81, 81 minus 81 is 0. In denominator also look, 3 minus 3 is coming 0. So this is 0 by 0 form, that means 0 by 0 form, use L'Hospital's rule. So according to L'Hospital's rule, what we will do? We will do the derivatives of the numerator as well as the denominator. That means limit x tends to 3, derivative of the numerator, that means derivative of x to the power 4 is, we know that 4x cube. Derivative of 81 is 0 because it is a constant term, by derivative of x is what? 1, and derivative of 3, so we know that is coming 0. So it is coming finally 4x to the power 3. Now you just put the value 4 into 3 to the power 3, that means 4 into 27, that means 108. Okay, this way we just solve by using L'Hospital rule. If it is coming 0 by 0 form, do derivative both numerator as well as the denominator. Then if after that you just put the value of the limit, that is x tends to 3. If I put it here, look, I will get this 108. Okay, next another problem. Maybe in one sum you have to use 2 or 3 times L'Hospital's rule. Maybe. Look, another sum. So one sum is given here. Limit x tends to 0 cos x minus 1 by cos 2x minus 1. Look, x tends to 0 cos x minus 1 by cos 2x minus 1. First you put in place of x 0. Look what it will come. If I put in place of x 0, cos 0 is coming 1. 1 minus 1 is 0. Denominator just check. Cos 2x, that means cos 0 is 1. 1 minus 1 is 0. That means it is also 0 by 0 form. So here you write 0 by 0 form. Use L'Hospital's rule. Okay, then do derivative both numerator as well as the denominator. So limit x tends to 0, derivative of cos x is sin x, derivative of 1 is 0, so this is coming only sin x. Denominator, look, derivative of cos 2x is, derivative of cos is minus sin x, derivative of cos 2x is minus 2 sin 2x, and it is coming 0. So minus minus cancel, that means it is coming limit x tends to 0 sin x by 2 sin 2x. Now look, if I put 0 here, Sine 0 is 0. Sine 2 into 0 means sine 0. Again 0 by 0 form. So here you write 0 by 0 form. Use L'Hopital's. Same statement. Again you have to do the derivative of the numerator as well as the denominator. Now look, if I do the derivative of the numerator and denominator, what it will come? Limit x tends to 0. Sin x derivative is cos x by 2 is there. Sin 2x derivative is cos 2x. As it is 2 is there, so 2 will get right at first. So it is coming limit x tends to 0 cos x by 4 cos 2x. Now look, if I put the value of x, that is x tends to 0, if I put in place of x 0, look, it is coming cos 0, that means 1 by 4 cos of 0, that is also 1 into 4, that means 4. So it is coming finally 1 by 4. So the answer is 1 by 4. Again from first just look, sum is given limit x tends to 0 cos x minus 1 by cos 2x minus 1. First you put in place of x 0. So if I put 0 here, cos 0 is 1, so 1 minus 1 is 0. Here also cos 0 is 1, 1 minus 1 is 0. So what type of form it is? 0 by 0 form. So 0 by 0 form, then you have to use L'Hopital's rule. Okay. Now do the derivative of that, of the numerator and the denominator. Look, limit x tends to 0, cos x derivative is what? Minus sin x. Cos 2x derivative is what? Minus 2 sin 2x. Minus minus cancel. So it is coming limit x tends to 0, sin x by 2 sin 2x. Look, if I put 0 here, again look, sin 0 is 0, sin 0 is 0. So again it is 0 by 0 form. So again you have to use L'Hopital's. So if I use L'Hopital's, so derivative of sin is coming cos x and derivative of 2 sin 2x is coming 4 cos 2x. So finally it is coming limit x tends to 0 cos x by 4 cos 2x. Now if I put the value of x is 0 here, so cos 0 is 1, here also 1, but here it is 4, so it is coming 1 by 4. So the answer of the sum is 1 by 4. Okay. Now move on to the next prototype, that is infinity by infinity type. Look this sum. Now look this sum, x to the power limit x tends to infinity e to the power x plus 3x to the power 3 by 4 e to the power x plus 2x square. Look, limit x tends to infinity e to the power x plus 3x to the power 3 by 4 e to the power x plus 2x square. Look, if I put infinity here, e to the power infinity is infinity, infinity to the power 3 is infinity, so infinity plus infinity is coming infinity. And here also look, e to the power infinity is infinity plus infinity square is infinity, so this is also coming infinity. So infinity by infinite form, use L'Hopital's rule. So numerator is coming infinity, denominator also coming infinity, so this is infinite by infinite form, use L'Hopital's rule. So how L'Hopital's means, you have to do the derivative both numerator as well as the denominator. That look, limit x tends to infinity, e to the power x derivative is e to the power x only, and 3 into x to the power 3 derivative is 9x square. Denominator 4 e to the power x, no change, and it is coming 4x. Again look, if I put infinity there in place of x, again it is coming infinity by infinity form. So write down here same thing, infinity by infinite form, use L'Hopital's rule. Again you have to do the derivative, do limit x tends to infinity e to the power x, derivative is e to the power x, no change. 9x square, derivative is 18x by, this one also no change, and 4x derivative is what? Only 4. Okay. Now look, if I put infinity here, again numerator is coming infinity. In place of x, if I put infinity, look, denominator also coming infinity. So again, infinite by infinite form, use L'Hopital's rule. So again do the derivative. Limit x tends to infinity. E to the power x, derivative is e to the power x. 18x, derivative is only 18. Denominator 4 into e to the power x, derivative is 4 into e to the power x only. And derivative of 4 is 0. Okay. So now limit x tends to infinity, e to the power x plus 18 by 4 e to the power x. Now look, if I put it here in place of x infinity, again look, e to the power infinity, infinity. So numerator is coming infinity, denominator also coming infinity. So again infinite by infinite form. So again what you have to do? You have to do the derivative of numerator as well as the denominator by L'Hopital's rule. So do. So again if we do the derivatives of both numerator and denominator, look, we'll get limit x tends to infinity, e to the power x, derivative is e to the power x, 18 derivative is 0 by 4 e to the power x, derivative is 4 e to the power x. We can cancel e to the power x, e to the power x. So next line, what we will write? Only 1 by 4, because these two are going to cancel, this and this. So 1 by 4 only left. So answer of the sum is 1 by 4. Look here, I used 4 times infinity by infinite form, that is L'Hopital's rule. So this type of sums we have to do this way only. If it is coming 0 by 0 form or infinity by infinity form, if we will get, that time we have to use L'Hopital's rule. And what is the rule? In case of in L'Hopital's rule, you have to do the derivative of the numerator and the denominator until or unless you are getting the real values. Okay students, so today up to this much. Next week again I will give the new chapter. I will explain to you a new chapter, and this week we will get some worksheets just based on this chapter. You just solve this worksheets at home and do in your fair copy, that all the worksheets you do in your fair copy. Okay students, thank you.